Good afternoon. I am Josh Conway. Some people would know me as Cranky Linux user, and I'm bringing the talk here, Meshtastic SDR. That's an SDR approach for a full Meshtastic receiver. And thanks to Mr. Taparel, who just gave this wonderful talk. His work is instrumental in what I was able to continue working with. So what is Meshtastic? So according to the Meshtastic devs, it's an open source, off-grid, decentralized mesh network to run on affordable, low-power devices. Now, what kind of low power are we talking about? We're talking about ESP32s. We're talking about NRF low power boards. It even runs on Raspberry Pis with a Wave Shield, which is an SDR, or not SDR, it's a LoRa shield for that. And all the devices I've seen so far use Semtech's LoRa transceivers. I believe it's like the SX 1272, 1276. It's around those, that line of product. And all of these use, it's a single transceiver type. And these devices are usually around $25 starting in to get into this platform. And as before we got into SDR and LoRa SDR, this was a proprietary. You had to buy their chip. And now with the SDR solutions available, that's no longer the case. So how does this actually work? So these little mesh devices will communicate back and forth between each other. They do use a peer-to-peer communication strategy. They do abide by different amounts of hops, so they will redirect and they will forward your messages to other nodes on the chain. Earlier today, I was communicating with somebody around 60 kilometers away through 3 hops to this network. And from here, you can see that normally your interface would be a phone, connect to your LoRa node. There are also LoRa nodes that are self-contained keyboards, if you see in the bottom corner there. So you can have it completely enclosed without any phone attached at all. They also have a lot of computer capabilities over Bluetooth or Wi-Fi. And then the one I added was the GNU radio to be able to communicate to the LoRa network and the Meshtastic network directly through a computer and SDR. So why an SDR solution? Well, Meshtastic and the Semtech hardware only supports, I call it a geometry, but it only supports one spread factor, one code rate, one frequency, and one center at a time. You can't really hop, and it takes time to hop those frequencies. With an SDR solution, instead, you can monitor multiple channels within the bandwidth that your SDR supports. What's really nice about this is even an RTL SDR, the inexpensive $20 solution, can monitor 5 of the 8 presets in Meshtastic. So a preset is those predefined LoRa geometries. And this device, just a $20 device, can get you listening in on Meshtastic's network for 5 of the 8, including the most common one, the long fast network. And then this potentially, so an SDR potentially allows receiving multiple channels at the same time, and then having, if you were to pair it with another SDR that can transmit, or with real hardware, you could listen and watch up to 5 channels at once, and then communicate out like you'd see in a traditional amateur radio repeater. This can bring Meshtastic and LoRa modulation to other frequencies. I did a test on the ARRL field day earlier this year on the 2 meter band, which is 144 to 148 amateur radio band. And that was an exceptional test to be able to bring that modulation and Meshtastic down to the amateur band. And along with this, having an SDR receiver and transmitter also allows for very rapid testing of bugs. So for example, the SDR flow that I use uses 0MQ. And because of that, it's just a byte stream. So you just shove byte stream into it and you can test whatever you'd like. And I've tested a few things of different bugs in the Meshtastic system that you can inject a random byte stream and test and see if things are acting as the way they should. Now, I have a YouTube video, if you go ahead and play that without audio, and I'll be glad to walk through how, Okay, so to run this, you first mirror the repository. It's over on GitLab this time around. Now, you do have to install Mr. Taparel's GR-lora SDR as it's a dependency. Once you mirror it, there's a few directories in here. The first one we're looking at is going to be the GNU radio directory, and that's where the script is for the receive and the transmit flows. They are different flows right now. Now, along with this, we also separate these out into the different frequencies, and then also European is 868 megahertz, US is 902 to 928 megahertz. So I also separate that out for ease of use for the people who want to use this platform. Okay, so here, there's 5 different flows here that are potentially running. The bottom one is the long fast. That's the default that people normally get put into with running Meshtastic to begin with, and it's the most common communication. Normally, real hardware can only run one of those flows, whereas this, once we execute this flow, we can actually watch all 5 of these flows at the same time. I'm using a hack RF in this case, but there's no reason for that. If I had an RTL SDR, we could run that. If you have a Blade RF, any front end would be perfectly acceptable to run in this situation. And we go ahead and run it, and we'll see in the bottom corner. Now, I did make one small modification to Mr. Taparel's code, and that was the debug switch to turn on SNR and the SFO and CTO. And that provides all the extra details of how the signal is and if it's good or not. Along with this, I'm using 0MQ, and we have the ports 20,000 through 20,004, each of their own ZMQ, so we know which port goes to which preset. From here, you see in the bottom corner there that we're seeing LoRa data right now. We're decoding it directly. And we now have to have another accompanying program in order to decode that data further, because Meshtastic also has its own data format. And this will parse the format to get the data out and actually give you the real messages, like the text messages. And you can see from here the debug modes. Basically, because it's all 0MQ, you just give it an IP address and a port, and it runs. And we'll go ahead and see that, and we can see some messages come up on the screen after we go ahead and run that. Yep. Okay. And this time I was actually going on my real device and then making some code, or maybe making some messages back and forth. Now on my current code, I actually had to implement an extra check. So this is a message for this ecosystem for text messages. If you're not running the 2.5, the newest version, direct messages are not secret. They're not encrypted any more than the normal communications are. So I found some messages that were being communicated, and it did not feel appropriate to allow sniffing of direct messages, because that's just not fair. But that's also now part of the code base to exclude that out of privacy. And as we see here, we have messages coming through, and we can see some messages don't decode properly. Part of that is because I do have CRC errors passing through turned on, so I do get some errors in there. There's also some protobufs, which is further down the data pipeline that I haven't implemented all the way, so some of those aren't being parsed correctly. But again, we have a full stream of all the different messages that we see on the network right now. Now this is, like I said, this is just the receive flow. There's a node announce message right there. And then we also have the transmit code as well. And the transmit code is the same flow, except it's another GNU radio flow. We're getting ready to go to that here on the video. And in the transmit, and I'm looking at adding these two together to not have to switch back and forth. But at this moment, they're separate. In this case, what we're implementing is the long fast, which I believe is SF12CR4, frequency 906.875, bandwidth of 250 kilohertz. And again, this opens up a port for 0MQ, except it's not 20,004, it's 30,004. So again, it's a simple, you send bytes into it, and it transmits it out only. And we can demonstrate that. And what I'll demonstrate here is I injected a node announce message. A node announce message in this Meshtastic ecosystem is to announce what your node's name is to the public. How do they call you? What name do they call your node? And all I'm doing is I'm sending out what's the clue server, which is currently running over in Bloomington, Indiana at my house. And I wanted to replicate that signal here, and that's what I did. And so it made it temporarily look like that my node was actually here instead of where it really is right now. And we can use a GNU radio, the transmit script here, as we see here. And we can just send the raw data directly into it, and it will transmit out over the air, over the HAC RF. And again, this works for any front end, so HAC RF, Blade RF, USRP, any other transmit compatible is perfectly acceptable. And I think this is the end of the video here. Oops. There. Awesome. And if you keep it on, on the screen, so this is actually what, and it was shown here just a moment ago, but this is what a LoRa transmission looks like as well, with all of the symbols like that. And again, this talk would not have been possible without Mr. Taparel's wonderful input and with GR-lora SDR. I would not have been able to be here and be able to do this talk without his exceptional work. And of course, it's also a dependency. And again, I'm Josh Conway. I do have code credit for the source code that was provided with Meshtastic SDR as listed, and my email. And then there's the QR code to go to the repo. Thank you.